So we're now on to the most challenging part of mechanics probably, which is moments. So before going into doing lots of problems, we're going to lay the groundwork a little bit because this will make it easier. I'm going to show you two ways that you can find moments with diagonals. So think back to chapter 4. You had some sort of support, a distance of 2 meters, for example, and then you had some other force. And here I've got the force of 10. So if this bit up here is the angle, one way that we could handle this is we could make a right angle triangle like this. We can say that cos theta is the adjacent side over the hypotenuse. So cos theta is equal to the side that I'm going to work out. Let's pretend I haven't worked that out yet, over 10. And in other words, I can get this number here. Now, why would I be doing that? Well, the idea is that when you have the force and the distance perpendicular to each other, you can multiply them. So you would do 2, and you'd multiply this one here. Okay, so the moment would be 20 cos theta Newton meters. Okay, so this is one way that you could do it. So you might think this is a little bit more like what we've been doing in chapter 5, say, but with a slightly different triangle. The other way we could do it is, again, we could have this 2 meters here, and we've got that 10, but what we do instead is we kind of extend that force. Okay, so we keep the force the same, and then we change how we express the distance. So for the distance, instead of expressing this 2 meters here, again, we sort of do our triangle again, and we instead express this one here. Okay, so it's a different way of incorporating the distance of 2 meters. You're expressing it as saying it's 2 cos theta meters to this point here. Well, why are we doing that? We're doing it because there's a right angle there. And you can see that the result is the same. So 2 cos theta instead this time, multiplied by 10, you still get the result of 20 cos theta. So what you're going to see in the videos here is I'm normally going to use an approach a bit more like the one at the top here, but I'll also show you how you can use this approach down here because it tends to be that one works better for most people. I often use which approach I think is best for the question that I have in front of me. So more specifically, what we're doing is it's not really just called ladders, it's called rigid bodies. So rigid bodies are ladders, planks, beams. They are things that do not bend or change shape. Rods as well sometimes come up, and you're going to see equilibrium come up in these questions. Well, equilibrium means the same sort of thing as before, but there's a little bit more to it this time. Okay, so most of the time for us, it's going to mean that we use up equals down and left equals right. Okay, so in other words, the ladder's not floating away or sinking into the earth, and it's not moving away from the wall or moving into the wall. It's not always a wall as well, but you should kind of see what I mean with these ones here. The new one really for us is this one here. So it says the sum of the moments around any point must be 0. So what does that really mean? Well, it means that the ladder cannot be rotating. Okay, so that sort of makes sense if you think about it. If you had a wall and you had a ladder up here, if the ladder is in equilibrium, which is what you would want, otherwise it's very dangerous, it means that the ladder can't be, it can't be turning. Okay, it can't be turning either way. So I often kind of express this as clockwise equals anti-clockwise. But what you'll do is you'll find that if we put all three of these things together, we're able to solve some questions that have lots of unknown information in them. And we're able to tackle things that are really quite difficult. So I'd really encourage you to focus on, with a ladder question, as they're often called, up equals down, left equals right, clockwise equals anti-clockwise. And this part, is going to be the most difficult for people, okay? So let's just practice that one more time before we get started. So on this question, I want to point out one final thing, which is, do you see the beam here is bold? Okay. Now, this is a giveaway that it's not, okay, it's not like a block on a slope question. It's definitely very much not this, okay? When you have a block on a slope, you're talking about the forces on the block. When you have a ladder question, we're talking about the forces on this ladder, this beam itself. That's why it's in bold, because the thing that's in bold is the thing that we're looking at. So you can see one force drawn here already. It's 40G. So that would be because this ladder, say, is 40 kilograms. So we assume that in the middle of it, pulling it down is its own weight, 40 grams. So we're going to try the two approaches here of doing a moment with this. Moments are usually taken from the base of the situation, or sometimes a hinge or something like that. So it's normally this point here. So for a moment, moments, remember, are the perpendicular, I'm going to kind of write it a little bit unusually. So the perpendicular distance times force. I put the perpendicular like that to kind of stress the fact that as long as they're perpendicular to each other, it's fine. So I'm going to show you one where you can manipulate the distance first of all. So what I'm going to do is I'm going to redraw this with just the key information involved. So I've got 15 degrees. I've got 5. 5 is the distance, 5 meters. And this 40G, what I'm going to do is I'm going to extend the arrow down. So I'm going to write it now as 40G. Now I need the distance and the force to be perpendicular to one another. So I'm going to keep my force like this. But the problem is this distance is not perpendicular. So I'm going to say that in this situation, this one here, this adjacent one, is 5 cos 15. Okay, and now I have a distance and a force that are perpendicular to one another, and I can just multiply them. So this is 200 G cos 15. Okay, so that's the moment created by that force there. So this is just one moment. And I could put Newton meters on the end as well. Let's do it now where I manipulate the force. So I'm going to start with that 15 again. I'm going to keep the 5 there, but how about this time, instead of changing the 40G, I'm going to say that that angle is 15, which should sound quite familiar. And I could draw the sine and the cos, but I don't actually care about that. I've got my 5, and I want to find the thing that will be perpendicular to it. So that will be, what would that be? That's cos, because that's adjacent. So that will be 40G cos 15. And you notice, again, if I multiply these together, it gives me the moment created by this 40G, which is 200G cos 15. Okay, so either approach works, but it does take some practice at the start to get into it. So this really is the key skill. Once you have this locked down, the rest of the questions do become quite a bit easier. Okay, so I'd encourage you to have a go for yourself, find some questions where you're just finding moments in diagonal situations like this to start with. Okay, but we're going to, in the next video, we're going to solve some problems in equilibrium, which require these 3 conditions here. Okay, and as we said, as long as you've got a consistent approach of doing it, that's what we're looking for.